very easy. Resonance energy in this given question, which is have highest. So we know that this is the negative charge delocalized like that. So here is also 2 pi bonds are there, or here is also there is 2 pi bonds, and here is the negative, and here is also negative charge. Now here is also delocalization of negative charge, and here also negative charge delocalization. But in this case, there is delocalization is possible two ways. From that side, delocalization is there, and from this side also delocalization is there. Both side delocalization is possible. But in this case, delocalization is continuously is there, but there is no continuation. Okay, so in which continuous resonance or continuous conjugation is there, so that consists the resonance energy is excess than the cross. So this is the cross conjugation. It is less. This is extended resonance, continuous resonance. Okay, understood? Right. Come to the next this example. Now this free radical is homolysis for the double bond. So at the same time, here is also cross homolysis, and here continuous homolysis. So continuous is the better than the cross. This is the cross, this is the extended resonance. Okay, and here is the oxygen is there, oxygen and carbon between the double bond is present here in the case. So oxygen, obviously electronegativity is more than the compared to the carbon. These pi electrons may be shifting towards the oxygen side, the carbon getting the positive charge. Understood? So after that positive charge, from the positive charge there is a conjugation is there. How it is there? Double single positive, sorry, double single positive. There is conjugation is occur. Okay, they're forming a conjugation. Here is also, there is also conjugation is there, but here conjugation coming to the both side, this side way and this side way. So two side conjugation is there, but here conjugation is continuous is there, continuous. So this is extended, this is the cross, but here is a conjugation is there, but there is only, how many pi bonds will be there? Only one pi bond. But in this case 2 pi bonds. Here is the conjugation two ways and 2 pi bonds, but here is the conjugation continue, but there is 1 pi bond. So the excess of conjugation here is there now. Okay, so that's why this is the extend resonance, this is the cross resonance, but here is a 1 pi bond is there. Because of that 1 pi bond is less resonance energy than compared to the 2 pi bonds. Here is also 2 pi bonds, but here is a extend resonance, but here is a cross resonance. But in this case 1 pi bond is there, conjugation is there. But here in this case there is no any conjugation, so there is no resonance energy. Understood? Okay. By the overlapping of electrons, their heat, or there is to maybe energy is released. That energy is called the resonance energy. By the overlapping of electrons, there is energy will be releases. That energy is called the resonance energy. Okay, there is no heat, there is resonance energy we have to say. Okay, right. Next one, here is the continuous energy, continuous resonance is there, but here is a cross. So which is better one? Continuous resonance is the better than the cross. The resonance energy here is the excess. Then come to the second one, and then next question, here is lone pair of electrons is present. So there is conjugation is present, double single lone pair. So here is also double single lone pair, but the lone pair which is easily to donate, which has less electronegativity atom, that can be easily to donate the lone pair of electrons. So electronegativity, nitrogen and oxygen comparison, oxygen is excess than the nitrogen. So the nitrogen of lone pair of electrons easily to participating in the delocalization. Understood? Right. So it's a resonance energy is the excess. And come to the next question. Now in this question, there is lone pair of electrons present on the oxygen atom. Okay. Right. Now in this question, there is 2 pi bonds are there. Here also 2 pi bonds, but here is a 1 pi bond is there. Okay. So come to the conjugation. So this is the conjugation is continuous conjugation, extend conjugation. But here is the conjugation is occurs both way, two sides, from that side and this side. This is we call the cross. But here is the two pi bonds are involved in the conjugation, and the second one in there also two pi bonds are also participating in the conjugation. So compared to the one pi bond, here is the resonance is more due to pi bonds are excess there compared to the last one. So excess of resonance, there is excess of resonance energy. Understood? So finally, extend resonance is greater than cross then compared to the one which is pi bond consist. Okay, right. Next one. Come to this question. We know benzene how many resonating structures will give? Okay, two resonating structures will be give, canonical structures. Okay. Naphthalene how many resonating structure will give? 3. In the last class I given the resonating structures numbers. Benzene 2, naphthalene 3, anthracene 4, phenanthracene 5. Keep it in mind. Benzene how many resonating structure will give? 2. Naphthalene 3. Okay. Anthracene 4, phenanthracene 5. 2, 3, 4, 5. So this is the naphthalene, this is the biphenyl. Biphenyl. So biphenyl how many resonating structure will give? 4 resonating structures. When there are pi electrons are in the delocalization, we are getting the 4 resonating structure for that biphenyls. So keep it in mind. Biphenyl how many resonating structure will give? There is 4, and naphthalene 3 and benzene 2. So we know that number of resonating structure increases, resonating structure बढ़िया है तो then automatically resonance energy will also increases. So understood? Next one, overlapping of lone pair of electron. This fluorine lone pair electron consists in the 2p and carbon consists of 2p orbital. There is the same energy level. So overlapping easily possible in the fluorine, then compared to the chlorine, then compared to the bromine. Due to here is a lone pair present in the 3p, here is a present in the 4p. The energy gaps very more in the chlorine and bromine with the respect the carbon. This carbon 2p, this carbon orbital 2p. So from the fluorine, lone pair of electrons easily conjugated. That lone pair of electron easily to moving towards the double bond side very easily due to carbon p orbital and that fluorine of lone pair of electrons there in the p orbital. So energy level is same. So when there is energy level is same, the flow of electron easily. Okay, right. Next, come to the next question. So finally, resonance energies excess in the which is consist fluorine and chlorine and bromine. Okay, right. Next, this is the azulene. So azulene, how many resonating structures it will give? In the previous class, already I said that how many resonating structure will give? It will be give 2 resonating structures, and naphthalene will give 3, benzene will give 2 resonating structure. So here is the azulene and benzene, they having the same resonating structures. Are you maybe there is a resonance energy equal? No. So here is the resonance energy 2, here is the resonating structures also 2, but benzene resonance energy 36.6 नहीं तो ऐसा याद रखो 36 kilocalorie per mole. Or the benzene resonance energy is a 36 kilocalorie per mole. But azulene produce the resonance energy 49 kilocalorie per mole. The value of 49 kilocalorie per mole for the azulene. What about naphthalene? 61 kilocalorie per mole. So now you tell me which has highest resonance energy. I will give the option 1, 2, 3. Which has highest resonance energy? Okay, very good. 3, 1, 9. This is wrong. Very good. 2, then after 1, then after 3. So naphthalene 61. Okay. Resonance energy is highest. Then after azulene 49. Then after benzene 36. Understood? Right. Come to the 10th question. So here COO minus, there are also double bonds you have to mention. So remove the there is hybrid structure of that oxygen. Sorry, hybrid structure. Right. Come to the 10th question. Here equivalent resonating structure will be there, but in this case normal resonance is there. So equivalent resonating structures, better resonating structures, due to all that resonating structures consist same energy level compared to the normal resonance. In that normal resonating structure, that each of resonating structure consists the different of energy levels. Okay, so the resonance energy is highest for the equivalent resonating structures. There is 2 pi bonds, and here is also there 2 pi bonds. Here also conjugation is there. Here also conjugation is also there. But which has highest resonance energy? For the question. So this is 4n pi electrons. It means there is 4 pi electrons is present. Hockel-Stern 4n follow kar raha hai. There is Hockel-Stern 4n. So this is anti-aromatic. But here is also 4 pi electrons, but it is not cyclic. Okay, so that's why this is non-aromatic. But conjugation in that 4, in that 2, there is same. Double, single, double. So there is number of pi bonds also same. So finally, which has highest resonance energy? Non-aromatic. We know that already. Aromatic is greater than non-aromatic, then anti-aromatic. So both are there in the conjugation. Both in that resonance is also possible. Okay. Right. Come to this second question. So obviously first is greater than second, due to here is the 4 oxygens is there, and there we getting the 4 equivalent resonating structures. But in this case there is 3 equivalent resonating structure we getting. So number of equivalent resonating structures increases, automatically resonance energy will be increase. And come to the third question. So here lone pair of electrons and double bond. Here is also lone pair of electrons and double bond. So this is also plesium, and this is also plesium, due to there is double single lone pair conjugation is there, so that nitrogen atom act as plesium group. Here is also there double single lone pair, here also plesium. So here to check the pi electrons may be moving towards nitrogen side, carbon getting the positive charge. And here is also oxygen getting negative charge, carbon getting positive charge. In that 2 pi bonds, which pi bond easily to migrate? Very good. So as per the electronegativity, oxygen is greater than nitrogen. So these pi bond electrons are easily to move towards the oxygen side than compared to the nitrogen, due to there is the electronegativity differences. So automatically here is the conjugation very easily possible. So compared to the first and second one, there is resonance is easily move. So that's why the resonance energy is excess for the second one than compared to the first one. Due to electronegativity is less, the delocalization is low. Electronegativity is excess, there is delocalization easily possible, fastly. Okay, right. Next, come to the fourth question. Obviously this is aromatic, benzene ring is consist, and this is 4 pi electrons, this is anti-aromatic. Okay, so we say the aromatic is excess resonance energy will give, then anti-aromatic. So compared to the, here is 3 pi bonds are there, there is a 2 pi bonds are there. So 3 pi bonds aromatic is forming in there. There is in the 2 pi bonds forming a anti-aromatic. Right. Come to the question next one. There is how many pi electrons are there? 8 pi electrons, including negative charge. So this is also from the pi bond in the conjugation. So that's why the negative also included in the pi bond electrons counting. Okay, so here also their pi electrons 8, here is the same. So same there is in the conjugation, here is also conjugation is there, so here also conjugation is there, but so 8 pi electron, this is the non-aromatic, sorry, this is anti-aromatic, this is non-aromatic, so it is not in there in the cyclic form, this structure, open state structure. So aromatic component must be cyclic or planar or complete conjugation, and must be follow the Haeckel's rule, 4n plus 2. There is 2 Haeckel's rule there, one is 4n plus 2 and 4n, which is to follow the 4n plus 2, that is aromatic, and which is to follow the 4n pi electron, that is anti-aromatic. Okay, so the component must be in cyclic or ionic cyclic. So there is no cyclic, so that's why that is non-aromatic. Of this resonance energy is excess, then the anti-aromatic. Right. Next, come to the sixth question. Here pi bonds are present, like the same 3 pi bonds. Here is also 3 pi bonds. Very nice. There is no conjugation. Here is a conjugation is there. Double, single, double, double, single, double. So there is possibility of movement of electrons, of that pi electrons is possible, but here is not possible of movement of that pi electrons. So if there conjugation, there will be possibility of pi bond delocalization. So there is no delocalization. So obviously its resonance energy is more than the first one. Okay. And come to the next question. And nitrogen consists lone pair of electron, and is besides there are also double bonds. So we know that here maybe electrons move towards the nitrogen side due to maybe the electronegativity compared to the carbon and nitrogen, their pi electrons towards to the nitrogen side. Automatically carbon getting the positive, and both side there is conjugation is there. So we know that there is a cross conjugation, cross resonance is there in this question. But in this question, so like the same 3 pi bonds, here is also 3 pi bonds, but here is a conjugation. Here is a conjugation, maybe electron coming to the nitrogen side, carbon getting positive. Their conjugation is continuous. Okay, so this is extended resonance, and compare the resonance energy of that both A and B. Obviously B is greater than A due to this is extended resonance, continuous resonance. Right, come to the question 8. A and B, very nice beta. So there is the cross resonance is there, this is the extend resonance. So B is greater than A, very good. So this is aromatic, this is anti-aromatic, this is non-aromatic. So there is no conjugation complete. So that's why there is a non-aromatic. This one question is non-aromatic, there is no conjugation. So obviously which is resonance give energy more? A, B and C. In that A is first, then C, then B. So here conjugation is there, double, single, double, but this conjugation is not in complete conjugation. So there is double, single, single, double. So conjugation break here. So that's why this is non-aromatic. Here is a complete conjugation, double, single, double, double, single, double. But this is the anti-aromatic. So we know already aromatic is excess resonance energy will give. Right, next come to the second question. Very nice beta. This is resonance energy will give more when compared to the first one due to there is conjugation excess. So here is only 1 pi bond is there, but here is a 2 pi bonds are there. 2 pi bonds, 1 pi bond. So conjugation is excess. So automatically delocalization is excess. Automatically resonance energy also excess. So I hope you understand of all these questions, resonance energy. Okay. So then next in the class I will explain the heat of combustion. Okay. So write down.